Okay, I just wanted to run through Cramer's rule one more time just because I was just not with it in class today. So I decided to color code the coefficients so you could kind of see better where they go in Cramer's rule. So if you have a system of two equations and two unknowns like this right here, you can use Cramer's rule to solve that. So you have your A and C are your X coefficients in that system of equations. B and D are your Y coefficients, and E and F are the constants. So Cramer's rule is that if you want to solve for X in that system of equations, you create this fraction where the denominator is the determinant of the coefficient matrix. The coefficient matrix is made up of the first column being the X coefficients and the second column being the Y coefficients. So the determinant of the coefficient matrix is in the denominator. The numerator is the same exact determinant, except instead of having the X coefficients in the first column, you put the constants in the first column. And then you work that out, and it becomes ED minus BF over AD minus CB. And that's what we had here. And then for the Y, if you're solving for Y, you have the same exact denominator as you had over here. It's just the coefficient determinant of the coefficient matrix. And then in the numerator this time when you're solving for, Y, not X, you just replace the column where the Y coefficient should be, and you put the constants, E and F. And when you work that out, you get AF minus CE over AD minus CB, just like you have here. Okay, so we didn't get to go over this problem in class, so I just want to go over it real quick using the law of sines to solve this triangle. So we have 23 degrees and 7, so we'll put the 7 in the numerator and sine 23 in the denominator, and that should equal, we've got 10, and across from 10 is angle A, so we can say 10 over sine A, and this will help us find A. So we cross multiply, 7 sine A equals 10 times sine 23. And then we divide by 7 on both sides. We have sine A equals 10 sine 23 over 7. And we get something like 0.5582, 0.5582. You are going to, okay, so inverse sine of 0.5582 is equal to A. And if you punch that into your calculator, you're going to get A equals 33.93 degrees. But if you look at the triangle, you can see that A is not 33.93 degrees. It's bigger than 90. It's an obtuse angle. So in your unit circle or in the XY plane, you have this angle, 33.93, that has this sign. But there's also another angle over here that looks just like it, that has 33.93 right there, that also has the same exact sign. So that's the angle, and actually this is the angle we want. That one right there. So 180 minus 33.93 is going to give you 146.07 for A. And if you add 146.07 plus 23 degrees, you're going to get 169.07 degrees. And we know that B is still left, so that's the final angle. And to find that, we will subtract this from 180 because the angles inside of a triangle all add up to 180. So 169.07, subtract that, and you get 10.93 degrees for B, and you can use that to find X. So over here, we will say that X over sine 10.93 is equal to 7 over sine 23. And when you multiply X sine 23 equals 7 sine 10.93, and then you divide both sides by sine 23, And you will get that x is about 3.4. All right, here's another one. With this one, we already have two angles, so we can actually find the third angle quite easily because we know that 50 plus 30 is 80, so 180 minus 80 is 100. So A is 100 degrees. And now we can start working on the sides, and thankfully there will be no ambiguity when we work on the sides. So we can say that 7 over sine 30 is equal to m over sine 50. So if we cross multiply, we've got 7 sine 50 equals m times sine 30. And we can divide both sides by sine 30. And so that gives us about 10.72 for m. And then to find k, we can say 7 over sine 30, we can use that again, is equal to k over sine of a, which is sine 100. And then cross multiply, and then divide by sine 30 on both sides. And so that is about 13.79. Okay, so we're looking at regular polygons. A regular polygon is just a polygon that has all equal sides and all equal angles. And we're going to be looking at learning how to find the area and the perimeter of a regular polygon inscribed in a circle. What we're going to do in order to do that is break each polygon up into isosceles triangles. The center of the circle, that will also be the center of the polygon. And then the radii of the circle, as you can see, are forming the sides of the isosceles triangle. And then the base of the isosceles triangle is the side, one of the sides of the polygon. And there, in the case of a square, there are 4 of those same exact triangles in there. If I'm looking at the pentagon, there are 5 of these exact same triangles inside. And for each of those triangles, you have these angles that are at the top of the triangle. And in the case of the pentagon, there are 5 of those angles. In the case of the hexagon, there are 6 of those angles, and they are all the same. And so, for example, in the pentagon, you can figure out what each one of these angles is just by dividing 360 over 5 in that one, and you get 72 degrees. And if you're talking about this hexagon, you would say 360 over 6, and that would be 60 degrees. So each one of these angles right here would be 60. And we'll use that information to help us figure out the area of one of these polygons. And then the height of each triangle coming down from the center of the circle or the center of the polygon to the base of the triangle, which is the side of the polygon, that thing is called the apothem of the polygon. So we want to find the area and the perimeter of a regular pentagon. That's 5 sides. That's inscribed in a circle whose radius is 6 units. So the way we're going to do it is we have broken up the pentagon into 5 congruent isosceles triangles where the sides are the length of the radius of the circle, and the angle at the top of the isosceles triangle is 1/5 of 360 because there are 5 of those angles. So we can just divide 360 by 5 and we get 72 degrees. I'm going to drop the apothem down, and that's going to split that triangle right in half because it's an isosceles triangle. And so each one of these smaller angles is going to be 36 degrees. So we're going to say that the sine of 36 is equal to opposite, which is that little half the base, over hypotenuse, which is 6. And so 6 sine 36 is equal to x. We can use cosine. So cosine 36 is going to equal h over 6. So 6 cosine 36 is going to be the height of the triangle. So we're going to multiply the base, which is 2 times 6 sine 36, because remember x is half the base of the triangle. And then we're going to multiply that by the height, which is 6 cosine 36. And we're going to divide that by 2. And that will be the area of one of these triangles. So that'll be the area of this triangle. And there are 5 of them, so we're going to multiply that by 5 to get the entire area of that pentagon. So multiply it by 5. So 85.6 square units for the area. And then for the perimeter of the pentagon, each side of the pentagon is twice x, which is 6 sine 36. So 2 times 6 sine 36 is one side, so we'll multiply that by 5 to get the entire perimeter of the pentagon. So this was the area, and then the perimeter is going to be about 35.27 units. Now we have a polygon of 8 sides, so an octagon, and it tells us that the perimeter of the octagon is 48. So if the perimeter is 48, that means each side is 48 divided by 8, and that would tell us that each side is 6 units. We know that there are going to be 8 of these triangles going all the way around that octagon, and so each one of the angles at the top of these triangles will be 360 divided by 8, and that is going to be 45 degrees. So that angle right there is 45 degrees. We drop down the apothem, and that's the height of the triangle. And so we split the angle in half, so that's going to be 22.5 degrees. And we split the base in half, so this is going to be 3. And so we need to find that height, so we can use tangent to do that. So tangent 22.5 is equal to 3 over h, opposite over adjacent. So that's going to be, h is going to be 3 over tangent 22.5. And that gives us h is about 7.24. So now we have the height of the triangle. We have the base of the triangle already. So 6 times 7.24 over 2 is going to be the area of each triangle, and then we will multiply that by 8. 173.82 square units.